according to this computer. Now, before we start our class of today, I just want to go through something, and I want you to be aware of that. So let me just go and share my screen. No, cancel. One sec. Let me just make this one open. Where is it? Where is it? Zoom. Let's share again. And here we go. So this is the syllabi for the class that the syllabi in the course page. And if you go to the bottom, and before I show you what do we have at the bottom, the other day I was just thinking about like those chapters are way too short for a 3 hours class. So I decided to go and double check on the schedules. And then I found out that last week we were supposed to cover chapter 5 and chapter 4 and chapter 5, but we ended up only covering chapter 4. So we are going to be a little bit short, but I'm going to try to figure this out. Today, we're just going to go with chapter 5, but starting from next week, we are going to cover 2 chapters in 1 week. Now, with that being said, let me just go back to the modules themselves. And let me show you something here. So last week in the weekend, I simply asked you guys to complete chapter 3 project, and I didn't have a chance to grade them yet, but I'll tell you I'm going to go there. Some of the questions are simply going to be automatically graded. Some other needs me to grade them. What I'm going to do, I'm going to double check on both of them, like the question that you answered and the question that needs my manual grading. Because I found out like sometimes a misspelling for a word, or having an extra space to the left or extra space to the right, may lead for your answer to be considered as incorrect. So I'm going to go and double check this weekend on all the answers and grade this part. Let's get back to today's class. Last week we covered chapter 4, more shell commands. What I'm going to do, I'm going to make this exam, this project, and this project, both of them available for you guys to work on them. And the time is going to be open, okay? And you just, again, those are going to be automatically graded. There will be like 15 questions. Each question is worth 1 point. You can get them done anytime you want. I'll just make them available. Just make sure you get them done before the due date, which is going to be this coming Monday. So both of them are going to be available. The good news about those exams is that all you have to do to answer them is to keep the exam open, since there's no time limits for it, and open your connection to the server and log in as a user and read the question and try to implement whatever he's asking you to implement. And then based on your implementation, you should be able to answer the questions correctly. So what I'm going to say here is that all you need is to find out time to get them done. With that being said, let me just repeat what I said. After the class of today, I'm going to make those 2 exams available for you so you guys can get them done by the end of this coming weekend. Next week, when we're going to come, we are simply going to be covering chapter 6, chapter 7, and depending on how long chapter 6 and chapter 7, I might ask you to start working on one of them. And today we'll see how far we can go today. And if we have time, I'll let you actually start working on at least one of them. But again, remember, time's going to be open. You should have no problems. So with that being said, if you have any questions at any time, let me just make sure that I open my chat window here. And if you have any question at a time, feel free to unmute yourself. Or if you would like to type a message, go ahead and do that. So what are we going to be doing today? Simply, we are going to go through the shell. We're going to try to understand the shell. And this is, again, a very, very short chapter. So I believe within 45 minutes or 1 hour, we'll be able to get it done. So let me just rephrase what I said. Probably I will ask you, I'll keep those 2 available, and I'll ask you to start working on one of them. And as I'm here, try to get one of them done if you can, or try to get them both done if you want. And if you have any questions, of course, just let me know. I'll be more than happy to help here. So With that being said, let's move on and let's see what do we have to talk about today. Let me open my PowerPoint file. I already had my connection to the virtual private network established, and I logged in to my account. So I'm going to be moving backward and forward between the PowerPoint and my terminal window. And we are going to talk about shells. Now, we talked about shell before, and we said shell is a program that will give you access to the kernel. And it's a program where there are predefined commands with their options and flags, where you as a Linux administrator, you need to be familiar with those commands and how do you use them. And simply, again, when you write those commands using the shell will interpret those commands into orders and pass them to the kernel, and the kernel simply will implement whatever you asked the shell to do. So by default, the shell that we are using in this server, it's the bash shell. And I can guarantee you, maybe 80% of the times you are going to be dealing with bash shell. And bash shell is not the only available shell. There's a lot of other shells that are available. Unix operating system, for example, has a shell called sh. Okay. But bash, again, it's the most widely used shell out there. And as I said, there are many, many shells. And here's what you need to understand, which is very, very important. Every single user in any server, like, again, for the example, the server that we're having here, we have many, many users. Every single user simply have what we call a default interactive shell. And that default interactive shell, by the way, you didn't choose it. It's simply going to be assigned to you automatically, depending on the Linux operating system that you have. If you want to know what's your bash shell, you should know, sorry, what's your default shell, just in case you want to know that. You can just type echo $0. It's going to tell you what kind of shell. But also, you should know that your default shell is simply decided and defined in a file located inside the etc folder inside the root directory, and that file called the password, PASSWD. If you go and open that file, and if you search for your name, you will find your name with a lot of information next to it in a single line, and at the end of that line, you will simply see what is the default interactive shell that you are using. So, how do I know what's my default interactive shell that I have in my system? Well, again, it requires me to go and check that file. And what I'm going to do, I'm simply going to do that right now and show you how do I know that. So let me switch to my terminal. Switch to terminal. Now you guys can see the terminal right now. Now, if I type pwd, it's going to tell me where am I located at. I'm inside home, faculty, Al Janabi. What I want to do, I want to get myself outside of this folder. So that will get me outside of the Janabi. And if I put backslash and double dots again, it will take me outside of the faculty. And if I put backslash and I put double dots, it's going to take me out of home. Now, if I go and type ls, it will show me that this is the root directory. Now, what I'm looking for is the etc folder. Here's the etc, so change directory, etc. And now if I type ls, and I'm simply looking for the password file. So if I take let's just go ahead with -L, you'll see that we have a lot of files here. Okay, so I need to figure out which one that I'm looking for is the ls password. So -L pass wd, and here it is. So here it is. This is my file that I was talking about. Now, of course, if I just come here and say cat passwd, you will see a very, very long file. And I want you to look here. All of those are users. All of those are users. And I'm pretty sure you are located here somehow. Let's see if I can find myself. You really, again, this is not, and if like, an efficient way to get the job done, what you need to do, you simply need to search for your name. Okay. To search for your name, we had this and we talked about it before. We have a method called grep, and grep will help me search. So I'm going to do type my username. Okay, so that's my username. And I'm just going to, again, I don't have to type password, passwd, because that's the file that I'm looking for. And here we go. This is me. And this is, again, showing me a lot of information about myself. This is my actual name. This is where my home folder. And this here is my default shell, which is bash in this case. Okay, so let me just go back to the PowerPoint. And as you can see here, for you to be able to search for a specific word in the password file, all you have to do, use the group that we covered last week, put your username, and then type. Again, this is this command here, assuming that I'm in the root directory, but I didn't have to put the etc because I was inside etc. Now, again, I'm just going to say it again because this is extremely important. You need to have a picture in your head about your location within the file system, and you need to also have an idea about how the file system looks like in your Linux operating system. That way, navigating, getting inside file folders, getting outside of folders will be very easy for you. So once you type that command with your username, you should be able to see something like this. Okay. Now, I talked about most of the information, like the default location, interactive shell, and also it's telling me the location of it, not just my default. It's telling me where can I find bash. It's inside a folder called bin. This is my home directory. Again, this is my name. And we have those two numbers that we are going to talk about a lot. Something is the user ID and a group ID. User ID, again, you are going to be identified by an ID. And also, in a lot of cases, you are going to be a part of a group. Like, for example, I belong to a group called faculties, and you belong to a group called students. The privilege and the permissions that you have are different than the permissions and the privilege that I have. Those usually privilege and permissions are assigned to groups in a different way. Of course, the same thing is applied to user IDs and to users. Also, you can see my username just like that. Okay, so this is, again, what do we mean by how is exactly, sorry, your shell is simply assigned to you by default. There's a default interactive shell. And if you really want to know what shells you have in your system, those shells are simply defined in a file called shells inside the etc. Okay, it will show you all the shells that you have. So let me just go ahead and show you that. If I go back to if I go here, again, remember here, I'm inside etc right now. So if I go and type ls-l, and we're looking for the file shells, he's telling me that this is the file shells. Now, if I type cat shells, it will show me all the shells that are available in the server. And you can see here, we have sh, that's available, bash, that's available, and this is the default one that I believe is assigned to everyone here. We have this here, no login. I don't think this is a shell, but maybe. I've never heard about it. Sometimes some shells are defined as some user folder. And we have sh again, bash again, tsh, csh, ksh, and there's a zsh, but it's not available here, and rksh. So you can see here many different shell applications that we have. And of course, by the way, you can use anyone you want by simply typing the shell, and immediately you're going to be moving from your default bash shell to another one, which I'm going to go through it in a few seconds to tell you exactly what happened when you are in your current shell and you try to run another shell. But again, those are all the shells that are available in your system, and they come part of the operating system. And again, each shell, by the way, has its own different format of how it's going to look like in the terminal window, what kind of commands are available. Most of them share a lot of those commands that we are using. They're exactly the same. So just to make it easier for everyone here to be able to use them. But again, some of these shells have their own advantages and disadvantages. But the thing that you should know that the most used shell is simply the Bash shell. And the reason why Bash shell, it comes with an open source, so you can actually have the text file of the Bash shell. And if you want to modify it, change it, of course, that's up to you if you want to do that. So if I go back to the PowerPoint, you will see that there's a list of some shells that we have. The TC shell, it's another version, extended and improved version of the C shell. We have the Corn shell, KS, and we have the Z shell. The Z shell that he's talking about here is not part of the Linux server that we are using here. I have a computer that is running a Linux distribution called Kali, and Kali Linux is simply designed for cybersecurity and for ethical hacking. And the default shell in Kali Linux operating system is simply Z shell. Okay, now with that being said, we are going to be moving on to a different concept and a different feature that Linux offers. And this is what we mean. Like, we were going to have something we call the parent shell and the child shell, and you can have grandchild shells as well. The idea here is very simple. Sometimes we call it subshells, by the way. If you are running a shell and you're trying to run another shell, now the other shell could be the same shell or it could be a different shell. The new shell that's going to be run, it's called the child shell. And the one that you are originally started with, it's called the parent shell. So to give you an idea about what I'm saying here, if I go back to my terminal and type bash again, that again doesn't mean that my original bash is going to be deleted or canceled and I have a new bash that's running. No, the new bash is going to be what I'm using, what I'm interacting with, but the original bash that I started with, it's still there. It's called the parent shell. And if I type exit, I will go back to my parent shell. And that simply is applied to all the other shells if you want to. Okay, so this concept also is applied to processes, not only shells. And we're going to see what do we mean by that. Sometimes you can run program or application from another application. And that's, again, what we mean by the parent-child relationships. So let's just go and have a look on the bash shell and the child. And so let me go to share my screen, terminal again. And I want you to pay attention to what I'm going to type here. If I come here and type PS, let's just start with that. Simple. What do you see here? You see the bash that I have here, and you see the PS that I just typed here. If I type bash again, now I have bash running. And look what's going to happen if I type PS. It's showing me that I have two bashes here. Of course, one of them is a child and one of them is a parent. But at this point, when you look at both of them, it's really hard for you to tell who's a parent and who's a child. Let's go ahead with the example that we had in the PowerPoint. If I type KSH, well, you know what? Let me just type SH. Okay, look, when I typed SH, how did the format changed? Now, if I type PS, you can see here, I got bash, SH, and PS. Okay. With that being said, now the question is, and let me go back, how do I know who's the parent and who is the child? Well, there are two ways to do that. If I come here and say PS -F, it will simply add a little bit more details, okay, to the output of the PS. Previously, I just got the PID, and I just got the TTY, and then I got the time, and then I got the CMD, the command. You can see that the CMD command is still there, and you can see the time is still there. TTY is still there. But you can see here that the user ID, which again, this is me, but those are the two parts that I want you to pay attention to. One of them is the process ID, and the other one is the parent process ID. Okay, so for the bash that you see with the hyphen here, the process ID is 8671, And the parent of this bash is 8670. Okay. I don't care about that for now, but let's look at the bash that I have here. This is its own ID, 12286. And the parent of the bash that I have here is 8671, which is the same ID of this bash. So this is simply telling me that the bash that you see here is the child of this bash. Same thing if you go to the SH here. This is the SH ID, and this is the parent of SH. And the parent of SH has an ID of 12286, which is the same as the ID of bash. So this is how you know. And if you look at the PS-F, you will find the same relationship here. This is the SH PID, and this is the child. This is the parent of PS-F. And this is, again, the parent ID, which share the same as the 1244, which is the SH ID. Now, there's another way that we can see it more in a graphical presentation. If I type PS for rest, okay, it's going to show you the structure of the relationship between those parents and child bashes in a form of a tree. Oh, he didn't like it. Let's see. Forest. Let me see. Did I misspell anything? Yep, forest. I wonder why he doesn't like it. Oh, maybe because I'm using SH, and SH maybe doesn't recognize the forest. So what I'm going to do, I'm just going to type exit just to show you. Now, when I type exit, pay attention to the prompt, how it changed. Now, if I go to PS, it will show me back the bashes. Let me run the KSH. And I can see here also KSH changed the prompt. Now, if I type PS, you'll see that KSH is there. PS-F, you'll see the relationship again goes back to the same thing. Now, let's try PS forest. Oh, here it is. This is exactly what I was looking for. This again, I'm just happy that this happened, just to show you that sometimes some bashes will not take the command that you typed. Okay, so just like how I tried to run the command PS forest, I know PS forest will work for bash, but I didn't know it's not going to work for SH. And here it is. So it can tell you here, PS here is the child of KSH, KSH here is the child of bash here, and bash here is the parent of bash here. Now, if I want to exit and go back to my original bash, this is extremely important and you have to be careful. If I say exit, I'm going to be leaving the corn shell. Now, if I type PS, if I type exit again, I'll be leaving the second bash and I'm going back to my original bash. If I type PS, you'll see that on my original. Now, if I type exit, I will get disconnected from the server, which again, I don't want to do that. It works. Oh, it works for SH? Okay, I don't know why it didn't take it in my side. I'll try to figure that out, because let me just go back and see. Did I misspell it somehow? Forest. Yep, here it is. Oh, the double hyphen. My bad. Okay. Thank you so much. It's a double hyphen. I was just wondering. It was I forgot to do the double hyphen here. I did the double hyphen, and it worked. Okay. Thank you so much, Nick. But just again, to a proof of point that sometimes some commands will not work in all the shells. Anyway, so let's go back to the PowerPoint. And again, this is the.
I have a question.
Go ahead.
It's kind of just a general question
Mhm.
regarding like the parents and children
Yeah.
shells. Why would you ever want a parent or a child shell? Like I'm just trying to understand like the use
Understand. Yeah.
cases.
We were going to
Yeah.
talk about something called the background process. sometimes you want to keep, for example, running some commands, some scripts using a bash and running some other commands using a different bash. Okay. It's mostly for optimization. And at a certain point, I'll just give it to you here. Sometimes you can have a processor that contain multiple cores, and you can assign a bash to each one of those cores by having that type of relationship.
Okay, that makes
Mhm.
sense. Thank you. Yeah.
Yes. So this is the forest. Let's move on and talk about how do we lose? How do we get outside? Oh, by the way, I forgot to mention here. Sometimes you can launch many shells and you get lost, so you have to be careful. This is a good idea to have a graphical presentation of the shells that you have. Okay, let's keep going. This is again just an example very similar to what we talked about. The exit command that will actually make you leave the current shell. You just have to make sure again, when you type exit, you don't exit your original bash shell, because otherwise you'll be logged out. Okay, now we're going to move on to a different concept, which is what we call a command list. Now, let me just tell you something, because this is mainly what are we aiming for. We want to learn about those commands and have a background about them as much as possible, because at a certain point during this class, we will get to a point where we're going to be creating scripts. Okay? Script simply means you write the commands in a single file and you execute that file. So there is a way that you can run multiple commands without the need to create a script file. And to do so, all you have to do is write your commands in a single line and separate them with a semicolon. When you do that, the compiler simply is going to run them all at the same time. So instead of you typing the command one by one, you can simply write them all and just put a semicolon between them. So how is that going to look like, and what is it going to look again? Let's go ahead and give it a try. If I go to my terminal and let me clear the window. If I type, let's go ahead and move back to, and you know what, let me just put it this way, change directory back to my window, user directory. And then after that, I will say ls -l, and then, well, I think it's called my files. I forgot the name of the folder that I have there. If I type pwd, and let me just start with pwd here and put the semicolon. And here we go. So those are 4 commands. The first command is going to show me where am I located at. And the second command is going to take me to my home directory. And the third command is going to show me what do I have in my home directory. And the fourth command will show me the home directory, the directory that I'm currently in. So press enter, and here we go. This is the output of the PWT. This here, there's no output for changing my directory to my home directory. This is the output of ls-l, and this is the output of this pwd. What you see here is simply what we call a command list. Simply, you can write multiple commands, and you can just separate them with a semicolon, and by doing that, all of these commands are going to be executed one at a time. Let's see here. A process list. What is a process list? Process list, when you put parentheses surrounding the command list, okay, it's simply going to be called a process list. Now, there's something very, very special about the process list when you do that. It's simply going to be executed based on running a new bash shell. So instead of using your default one that you started with, it's simply going to start a new one, and in the new bash shell, you are simply going to execute all these commands line. So let's go back to terminal here. Where is it? Okay, let's go back to the terminal. And I'm going to simply, let me change my directory. And let's get out of here. Now, if I type ls, this is the root directory. Now, I'm going to try to copy this command. So I copied it. Before I do anything, I'm just going to type ps. And you can see here, I got the bash and I got the bash. Now, here's what I'm going to do. I'm going to start parentheses, and I'm going to close the parentheses. And here, I'm going to put the commands. This, again, will get the same job done. It's going to simply start by showing me my current location, and then it's going to change me to my folder, user folder, type the ls, and the pwd, and here we go. Now, let's go ahead and put ps and see. Okay. See, a parenthesis matter because it caused a subshell to be created to run the commands. Okay, even though you're not going to be able to see the command that was just generated, but it simply is going to get the job done, and it's just simply going to, let's see here. Why am I not seeing the bash? It's not your number. Okay, for some reason, I don't know exactly if I'm supposed to see this or I did something incorrectly. But I know the parentheses, when you run them, is going to be run on a new subshell. But is that going to simply terminate it after the execution? That's the part that I'm not 100% sure about. The parentheses matter because it's going to cause a subshell to be created to run those commands. Okay, so let's see here. Maybe if I follow these instructions. Yes. I just realized this again here, because the PS force is going to be part of the command list, you'll be able to see it. But if you actually, this is the only way you can see that bash that was generated, because it's part of the command. But after you execute them, you're simply not going to be able to, because it's going to be terminated automatically. So let's go ahead and follow here. If I type ps forest, you can see here, I got the bash, I got the dash ps. Now let's go ahead and execute the commands. Well, you know, let me just get out of here. Change directory. If I type ls, I'm in the root directory. And here's the part where I'm going to actually put those commands. And here, I'm going to add ps forest. Okay, just to execute that command line while I'm executing the command list. And you can see here, I got this bash. But if I try again to type ps -- forest, oh, wait a minute. Yeah, here it is. You see, it doesn't exist. So what is the conclusion of what I'm doing here? This command list, even though it's gonna create a new bash for you to execute the commands between the parentheses, once those commands are executed, that bash will automatically be terminated. And this is again what we call a process list. So we have the command list and the process list. The difference between them: process list comes with parentheses. Command list doesn't contain parentheses. Process list will create a new bash, a subshell, to run those commands, and then after that is going to be terminated. Now, at this point, in addition to what I said, because the other day I was looking for why would we have a background process, foreground process? Why would we have, as you can ask before, why do we have a subshell or a child shell? This is a good idea to go and do a research about this. Try to collect as much information as possible about why would we want to do that. But again, I remember when I read it, the one that sticks in my head is for optimization and to be able to utilize the multiple cores that you have in your system. Sometimes you want to have a bash to get multiple bashes to get different jobs done separately. Now, let's move on to another concept, which I was going to talk about, which is the background and the foreground commands. Now, we talked about sleep before, and we said sleep will simply put your command terminal into a sleep for a few seconds. And let's go ahead and give this a try. This command here, where is it? Sleep 5, PWD, sleep 5. So here we go. Sleep. Come on. Sleep 5. And I'm going to use PWD, sleep 5. We're going to sleep for 5 seconds. And then we should see our location, which is the root directory. And then we should sleep for another 5 seconds. And then we get back to our original. This is, again, those commands are executed one by one in the foreground. You are actually seeing what's going on here. Sometimes, okay, especially when we need delay, we want that delay to be working on the background, but at the same time, in the foreground, we want to be able to interact with the system. Sometimes, again, we're going to learn when we get into the deep of the operating system. Some commands, you want them to be executed, but those commands, as they execute, they take time. So you don't want to sit there waiting for them to be executed. You can run them in the background where you're still going to be able to interact with the shell itself. Sleep here is just an example to show you a process that takes time. Again, depends on how long you want it to run. So how do I change? How do I make my program to run as a background mode? All you have to do is to follow that command with the ampersand. Okay, that way it's going to be executed in the background and you will still be able to use the foreground. So if I come here and let me copy this, and you know what, now, instead of that, let me just, let me just start with a new one. I will say PS, not PS, sorry, sleep and then echo hello Linux. Now, of course, if I press enter, I'm going to have to wait for 10 seconds. And then after that, it's going to be printed, but I want it to run in the background. So if I press, you can see here, it's executing in the background, but you don't see it. And now I can interact typing ls, for example, and it's going to work. And look what just happened. Immediately after the 10-second passed, I saw the message printed on the screen. And that's, again, what we mean by foreground. So as a network administrator, as a Linux administrator, whenever you want to write any command and you want it to be executed in the background while you still can interact in the foreground, you can use that ampersand. And again, this is also very important when you're going to write script. If you have a command, let's say you have a script, and in your script you have, let's say, 10 lines of code. If you want your program to execute, your script to be executed, and let's say that one of the commands will take, let's say, 10 seconds, you can make it run in the background. So the other instructions that comes after it will be executed. And by the time they're executed, maybe that one that takes a long time will be done after that. And that's simply what we mean by foreground and background commands. Okay, let's keep going. If you want to view, and let me just go back to the command line. If you want to view the jobs or the processes that are currently running in your background, you can just write a command called jobs. Like that. And you can see here, there's nothing running. Well, actually, this one was executed in the background, and it's telling you it's done. It was executed, and it's done. Now, let's just go ahead and type sleep. And let's put a command that will take, for example, 20 seconds. Okay, and let's put it as a background. And now if I type jobs, it will show you that sleep 20 is running right now. Okay. I'm just gonna wait for, let's say, 15 other seconds. Let me just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's hope that's 10 seconds. It's done right now. Of course, it was not 10 seconds. It's exactly 20 seconds, but because I was talking, that was also counted, so it's done. So jobs, again, it's a command that we can use to have an idea about what's running in the background. Now, why would you want to use background jobs? Again, as I said, if you have a process and if you have an operation that will take long time, you will always want to keep that job running in the background. So you will not force to be sitting waiting for it to be done until you can actually take control and continue using your Linux operating system. That's, again, one of the most important parts. Why would you want one of the multiple reasons why would you want to actually run your program as a background? Okay, now let me just move back to the PowerPoint because we're going to be moving on into something a little bit different. Commands types. Mainly, we have two different types of commands. The first one's called the built-in command, and some other commands, we call them the external commands. Built-in commands are part of the shell itself. Okay, they are built as a part of the shell. External commands are simply commands that are not part of the shell, but the shell recognizes them and can utilize them. And we have a different names for them. We call them file system commands. So both of them are executable. Let's put it that. Both of them are interpreted and understood by the shell that you're using. But one of them is part of the shell, and the other one, no, somebody created it and added it to the shell. So it's not part of the shell itself. If you want to put this in another term, most of you guys did programming before. We have what we call primitive data types and non-primitive data types, if you want to think about it that way. Primitive data types comes as a part of the programming language. Non-primitive data types are data types that are created using the primitive data types. So the built-in commands are simply, again, part of the shell itself. It's built with the shell itself. External commands are simply not part of the shell, but the shell understands them and can use them. So why is this important to know? Because external commands simply are executed using a child shell. So if you have a command that is a built-in command, when you execute it, it's going to be executed by your default shell that you have. But if you have an external command and you try to execute it, the first thing going to happen, another shell is going to be executed, and that child shell or subshell is going to execute that external command. Now, the question is, how do I know if a command is a built-in shell or a built-in command or an external command? Well, we have a method called which, and after you type which, you follow that with the command, and it's going to tell you if it's a built-in or it's external. But before we jump into that, we have, let's say, look at this example. Wait, no. I made a mistake. My bad. Wait, no, sorry. The type, the command is type. My bad. I jumped a little bit further. The type command, sorry, is going to tell you if a command is a built-in or it's external. The which statement, which simply going to tell you the absolute path for the command. Where does that command simply exist? Again, remember, a single command, it's in a program by itself. So let's go ahead and give those try and see how do they work. So first thing first, let's see. If I type, let's try this. Type exit. Exit is a shell bin. Shell built in. Let's try the PS. PS is hashed. Okay. I'm guessing hashed is it's not a built-in. Let's see here. Sleep. Yep. You can see here, sleep is not a built-in. Let's see type by itself. Type is a shell command. Let's say type ls. ls. Okay. Now we're going to talk about these LIs. What do they mean in the future? Okay. So today, I mean, we're going to talk about what those LIs simply means. LIs, I don't want to talk about it right now. We'll talk about it later. Let's go and type another type of command, but he's not telling me. Well, if I want to actually know, I have to type ls -- color equal photo. Not found. Did I misspell anything? Say type ls. Maybe I have to surround it with quotation marks. I'm guessing it's not only tell you about if it's external or if it's a built-in, it's also tell you if it's an analyzed command as well. Anyway, let's keep going. Let's go with which and see how which work. If I type which ps, it's going to tell you that the command ps does exist in a folder called user bin ps. Let's go with which ls. And here it is. It's inside bin. Which exit. Oh, look at the exit. Where's it located at? Let's see here. User bin which. Not exist in. Well, where does it exist then if it's not exist in any of those? Anyway, you need to read the whole thing so you can be able to tell where does it exist. So type will tell you what type of command that you have, which will tell you the absolute path of where that command simply exists. Now, with that being said, let's keep going back to the PowerPoint. And at this point, we're going to talk about forking. Now, forking, whenever an external command, this is what I was talking about. Whenever an external command is executed, it simply means a child process is created. Okay, and I want to show you that here. So you can see here, when I typed ps-f, the parent of ps is simply the bash that you have here. This process is simply called forking. Okay, and this is not the case, by the way, for built-in commands. So if let me go back here. Let's see which one of them was a built-in command. Type is a built-in command that we saw before. So if I go, let me get back to terminal, so I'll show you that. And let me clear this. And I'm going to go and show you a built-in command. Okay. So if I type type, and I will change directory, for example, it's a built-in command. Now, if I type ps hyphen or f, well, he didn't show me the type cd command here. But the most important part you can see here, ps that we talked about before, it's not a built-in, and for that reason, you can see that the parent of the ps is simply the bash that you have here. Okay, so again, this is simply applied to processes. If you have an external command, and that external command, again, if you try to run it, it's going to be considered as a child for the original bash that you started with. Okay, now, when it comes to the efficiency, of course, the built-in commands are way more efficient compared to the external, because the built-in are going to be executed by themselves directly, while external commands will, as I said before, they required to be created as a separated child process. And for that reason, they are going to be not as efficient as the built-in commands. Now, the last part of I think built-in commands do not have path because they are built into the shell. Probably. Yes, I think that's the reason. I'll look into that. The last part I'm going to talk about here is the history of, sorry, the last part. We have two pieces to talk about: history. Now, every time you type a command, it's simply going to be stored in what we call the log of the shell system. And if you just type history, it will simply show you all the commands that you typed in your shell. So if I just come here and type history, and here we go. So these are all the commands that I've been typing today ever since we start the class. Look at that. Many commands. Again, just because I type the command multiple times, it's going to repeat and show me all the commands. Now, the thing you should understand here, if I want to have access to those commands, you can use the arrows to go up and go down to navigate through all these commands. So just in case in the future you find yourself writing a lot of commands and you feel lazy, you don't want to actually type them again, up and down until you find the command that you actually want to run. So that's the history. And I think you should be able to clear the history if you want to. And to clear the history, there's a command I don't remember right now, but you can actually clear the history if you want to. If you want to run the last command that you typed, just by typing those two symbols here, you should be able to run. Now, if I go back to my, I don't know if I was actually showing you the history, but let me just go back here to the terminal. Let me clear. And if I type history, it will show me that the last command that I typed was history. And then before that, I was clear. Let me just type ls-la. And now that's the last command that I typed. And if I just go back and type those two symbols, it will actually run the last command, which is, again, is show me this command again. Okay, let's go back to the PowerPoint. So that was the history. Now, the last part, I believe, is the lis. What does lis simply means? Sometimes, and you're going to find yourself doing this a lot, you're typing a command, and that command contains many arguments, many flags, many options. And you say, I really, really wish I can have a shortcut to get this whole command executed without the need to write every single one of those words and that long command. Well, you can do that. It's a way that you can customize the command for yourself. The idea here that you have to type the word lis, and then after that, you type the new command that you want to use and type equal and type the command that actually does exist with all the details that you have there. Okay? Let's take this example here and show you how does it work. If I go back to my terminal and I will type the following. lis. Okay? And I will type here hello world equal, open parentheses, echo hello JCCC. Command not found. Well, did I misspell it? Oh, yes. Oh, yeah, of course I did. lis. Let's go ahead and do that again. And now if I just type HW, it will simply execute echo hello JCCC. Again, this is a feature that you have that will let you customize the commands. So sometimes your commands could be very, very long. Instead of when you want to use it multiple times, then you can simply just type lis with the new command that's going to be a short form of that command. And that's how it works. Okay, so at this point, we are done with the PowerPoint file. Let me stop sharing, or let me, move to my Canvas page. And let me tell you again about what did I start the class with today. I showed you in the syllabi that last week we were supposed to cover chapter 4 and chapter 5, but we didn't do that. So last week we covered chapter 4. This week we covered chapter 5. Next week we're going to cover chapter 6 and chapter 7 within one class. That makes sense, especially those chapters are very, very short. Now, for those two chapters, you simply have those two exams to get done. What I'm going to do at this point, I'm going to make them available. Okay, let me just go ahead and make them available. The due date for them is going to be, and let me see the calendar here really fast. It's going to be 12th, okay, of February. I'm going to make the time open, and I'm going to make the due date very clear for you. Make sure you get it done before the due date. Remember, this is going to be executed graded automatically. Make sure again that you submit your grade. There's a message, by the way, at the beginning of each one of those exams that will tell you to pay attention to a few points, because again, answers are case sensitive. Extra space, uppercase, lowercase, will have a negative effect on your final grade. So, let me make them available, change the settings. I'll make it available on 12. Okay, let's change the due date to 12. Okay, and remember here, there's no time limit. There's a single attempt, and I'll take this one away. Let's see the response. Incorrect question will be marked in the student feedback. Okay, so I'm gonna save and publish. So that was last week. Let me move on to this week. And let me just remind you about what I said earlier. I said the best way to answer those questions is simply by opening your terminal or your Linux account, and whatever he's asking you to do, just get it done. Okay, so let me go ahead here and let me save it. So now you have both of them available, and you can start working on them. What I'm going to do at this point, I'm going to give you guys a break for 15 minutes, and then I'll come back. And when
I
I come
have
back,
question. I'm
go ahead.
sorry. Yeah, you say available for in the still February 12. I saw there. Not now.
What do
Today
you
is the
mean? Can you
7.
repeat that again?
Is the assignment you
Those
put in the
assignments, the
available?
5 and 4.
Yeah, open to 12. I saw there, but I don't know.
Yeah, they're open
Okay.
till 12th. You should have access to them. Again, just make sure you get them done before 12.
Oh, okay.
Okay?
Mhm.
Let me stop sharing. Let me stop recording.